Hey there and welcome back. So I'm 2 weeks into summer school and I'm seeing a lot of problems with this, how to complete the square. So I think sometimes students aren't sure what they mean by a square. So what they mean is a perfect square trinomial. So to make this a perfect square trinomial, the easiest thing to do is to take half of the linear coefficient, divide it by 2, and then square it. So I could write x squared minus 4x plus 4. But, and a lot of students are doing this, but we still have this plus 1 that was in there already. Number one. Number two, can I just add 4 and not change the value of this expression? And the answer is no, I can't. So I have to subtract 4 as well. So x squared minus 4x plus 1, x squared minus 4x plus 1, plus 4 and minus 4, that goes to 0. So now this is the perfect square trinomial that goes to x minus 2. This 2, the minus 2, is half of this negative 4. And we're squaring that. Then I have to add these two things together and say, aha, x minus 2 quantity squared minus 3. So these students that I'm tutoring this summer are Algebra 2 students, so soon they're going to find out what's so special about this vertex form of a quadratic. So let's look at one more. I'm going to pause. We'll put one more up. All right, so here we go with 2 of 2 examples. N squared, we're going to switch from x to n. And believe it or not, sometime I've had students actually ask, is it the same for n as it is for x? Yes, of course it is. So I want to complete this square. So I want to add half of 10 squared. So I'm going to start, I still have a minus 32 here. So half of 10 is 5, and 5 squared is 25. So that's where that's coming from. But can I just arbitrarily add 25? And the answer is no. So I still have to maintain the value of the initial expression, n squared plus 10n minus 32. Plus 25 and minus 25, that doesn't do anything to the value of this expression because those add up to 0. But what I've done is completed a square. So n plus 5, remember this 5 is the half of the 10, and that quantity is squared, but then I have minus 32 and minus 25. So when I add those together, I get minus 57. All right? So these two things are equivalent, just like they were in the last example, but this is written a little bit differently. We've completed the square so that later on near the end of Algebra 2 and all throughout calculus, pre-calculus, we can put things into a mode that makes it very easy for us to graph. So that will be coming up in a future video. If you'd like to see how to graph these, let me know in the comments down below. In the meantime, I hope you enjoyed those 2 short examples of how to complete the square.